Hi. Today we came here to talk about how we build an air-gapped control plane or control planes, because we can scale this up as much as we want, for Novo Nordisk, the company I work for. This is us. I'm Juan Gonzalez. I'm a lead platform engineer in the software engineering platforms team in Novo Nordisk. Probably most of you know already, but Novo Nordisk is a global pharma company. We're leaders in the field. We have more than 100 years heritage producing medicine for diabetes, obesity, and rare diseases. And I have Yury today with me as well.
Hi, I'm Yury from Abound. We are creators of Crossplane project. Super excited to be here. Juan, please kick us off.
Yes. What are we going to talk about today? We're going to introduce you to what EMIR is. EMIR is our control plane over our platform. Where do we stand in the pharma industry? Why do we have to do this in our industry, and why it's so important to have air-gapped control planes? The solution that we together came up with, some challenges we faced, and then we're going to show a little demo at the end and how we deploy changes, test everything out, make sure everything is secure and reliable. So what is the EMIR platform? EMIR is the first giant on the Norse mythology, so it's where everything comes from. That's what inspired the name. And this is the name we chose for our control plane. In the end, EMIR spawns Kubernetes clusters that support our developer applications. And we want to be as agnostic as possible. It's really important for us because we have all kinds of environments. We have on-prem, cloud, and I guess that's it. And then our main objective with the platform is just to enable developers on focusing on business logic and just abstracting away from all the boring stuff like compliance, security, and things that developers don't really want to do. Developers want to develop, and that's something that we kind of repeat ourselves because this is our objective with EMIR and with the platform. So we empower them to build cloud-agnostic applications, so we can move them around as much as we want and with very little configuration changes. So what role does EMIR play in pharma and regulations? Well, pharma is one of the most regulated industries in the world. And of course, we cannot get away with it. And compliance for us is vital. And it's vital because our IT systems support the production lanes for our medicine. We manufacture and distribute pharmaceutical products that depend on our IT systems. So we need to ensure that this chain is never broken. We need to be compliant because if this chain breaks, people may end up without medicine. So it's not only that you cannot just access a website for a couple of hours, it really has an impact on the real world. So maybe you don't know, but even though we are 100 years old, the IT in Novo Nordisk, the internal IT, is really, really young. It has like around 6 years or something like that. But of course, this comes with lots of challenges, and compliance being one of them. At the beginning, everybody started doing anything. There was not too much control outside the production lines. And of course, we wanted to come to a solution. We needed to come with a solution that streamlined compliance and allowed everybody to develop from a single base that is proven to be secure. So that's what inspired or what led us to build an air-gapped environment. Security is vital for us, and in the end, our control plane has the keys of the kingdom. It has access to most of all of our infrastructure, and if that gets compromised, it's very, very dangerous. So also, EMIR in the future will be deployed into our production systems, into the production line systems, and those computers are completely disconnected from the internet. They do not have access to anything, and they need to run on site and completely isolated. So this also inspired the solution. And of course, this means that we need to ensure as minimal human interaction as possible, ideally just in emergency situations. So everything needs to be as code. Everything needs to be done using GitOps. So how do we bootstrap a cluster in an air-gapped environment? Well, Crossplane needs to run on top of Kubernetes, but what spawns the first Kubernetes cluster in which Crossplane is going to run on top of. This poses, of course, a chicken and an egg situation, how you deploy the cluster, and then going to deploy other clusters, and then other clusters. So we need to create a mechanism in which we don't have too many tools lying around. Of course, we can have Terraform, of course, we can have other solutions out there, but we chose Crossplane, and we can use Crossplane for this, and we don't need to go for other solutions. So we can test everything from the same source of code. So, and of course, we're not going to do that manually. We need to trace everything. So yeah, we use GitOps. We need to have everything as code, of course, because of compliance. Every change needs to be traceable, and you also need to be you need to be able to reverse to a previous change in case you break something. And you need to do it fast, because every minute a production line is stopped is very, very costly. So, and of course, we need to test every change before we deploy it. And if we have a small code base and we use the same technology and we use the same source of compositions for Crossplane in our case, the process is much easier for us developers, platform developers, and also for the users of the platform. And we just found out that Crossplane and ArgoCD work together really well to test compositions and to also deploy infrastructure. So Yury now is going to talk us about the solution we came up with.
Yeah, right. Let's jump into the solution. So first thing first, like a little bit of stage zero context, right? So we are going to use a very practical terms of Azure environments and specific resources that we are going to operate. At the same time, the principles are applicable to any cloud environment and even on-prem. So first idea that came to mind when we were building air-gapped solution was like a private AKS cluster, right? So what could be easier? If you know the structure of this managed resource in Azure, and if you're familiar with Kubernetes cluster, in a provider Azure, you know that there is single flag, right? Private cluster enabled, you can flip it, and it kind of becomes air-gapped. Well, what could be easier? Obviously, like as it frequently happens, our expectations were broken with the first end-to-end test, so reality is much more complex. So the complexity here is easy to understand when we compare with the public AKS cluster scenario. So we have a bunch of reference examples. We have a very stable composition. Novo Nordisk, how to deploy public clusters. The main difference is actually access to a standard Kubernetes API. So if we look at a public AKS scenario, it's kind of easy. So we have a Crossplane instance, we have a couple of providers there. So with provider Azure, we can talk to AKS Kubernetes API on the cloud provider side, and we can say, like, please deploy a Kubernetes cluster for us. Then later on, we ask provider Kubernetes to configure the clusters through a standard Kubernetes API, like deploy arbitrary things, configure service accounts, whatever we like, right? So this is very straightforward scenario. Private AKS is a little bit harder, though. We can still ask to deploy a Kubernetes cluster because Azure APIs are public, but we cannot talk to the cluster directly because it's air-gapped, right? So we don't have a public access at all. So that's a trick. We need to solve that. The solutions that we came up with, so the start of the solution, is a shared private network that we are going to prepare for our private AKS cluster, and we will put a Bastion type of virtual machines there, so we will have some form of bootstrap mechanism and a Bastion servers for like admin-like connectivity. It will look like that, very simple, first stage environment, right? Private network, Bastion VM, Azure Bastion service. But how to deploy even that stage, right? We need something to deploy this first stage, and it's another chicken egg. So we have quite an amount of chickens and eggs in this story. And we evaluated a couple of solutions. Crossplane for us is like a default. Obviously, we are pretty much aware that in community, it's pretty frequent that folks are solving these bootstraps challenge with the Terraform or OpenTofu. We wanted to stick with Crossplane because we wanted to same kind of, apart from the fact that we love Crossplane, we want to stick with a single consistent manner to deploy infrastructure and also reuse abstractions and test them in with the same style of pipelines. So how we do that? This crossplane within a GitHub action. So one of the main counter-argument to use Crossplane that we hear about is actually like the Crossplane itself needs a Kubernetes cluster. So how to get this cluster before we even use Crossplane? To enable it within a GitHub action itself, we will need to perform kind of amount of steps, like deploy a kind cluster on a GitHub runner, install Crossplane there, deploy a Crossplane configuration, configure credentials, and finally deploy an actual composite resource for our Bastion environment. So amount of moving parts is pretty high, but luckily we have a tool called uptest that nicely abstracts everything, this setup. So uptest, the main purpose of the tool is actually end-to-end test automation framework for your cross-plane compositions. If you're interested in the testing part of it, we have an in-depth talk that we delivered together with my colleague Steven back in Hong Kong in China. But here in this part of the story, we will focus on a bootstrap mechanism, right? So for uptest, to test stuff, it needs to prepare the crossplane environment. So meaning like deploy this local cluster and configure crossplane on top of it. That's exactly what we will use as a stage first bootstrap in our story. So we will put uptest within a standard GitHub hosted runner, the managed one. Uptest will deploy a local kind cluster for us, and a crossplane will be configured there. So after that, we can easily instantiate this X-Bastion abstraction that will encapsulate the actual deployment of Azure Private Network, Bastion, and Bastion Service. So we solved this first level chicken egg. Great. We have a bootstrap available. It's kind of air-gapped Bastion, but how to use it, right? It's air-gapped again. So the similar problems that we discussed before, we do not have any convenient way to connect to it. Bastion service is there, but it's only for admin-like emergency situations only. So solution is actually to register Bastion VM as self-hosted GitHub runner. So when we deploy on the first stage this X-Bastion abstraction, it encapsulates the logic to register in automated way the Bastion VM in with your GitHub actions. So the Bastion VM becomes a self-hosted GitHub runner, fully integrated with your CI/CD environment, and effectively it provides this kind of legitimate backdoor to air-gapped environments. That's exactly what we want here, because we will have a seamless authentication and ability to run stuff in convenient way on a Bastion VM within an isolated environment. Now, as we solve this connectivity issue, now it's time to create a crossplane cluster within an air-gapped setup. We will use uptest capabilities for bootstrapping again at this stage too. So we will run on top of on a stage 2. We will run uptest again on within a Bastion VM, and we will deploy a local cluster with uptest with crossplane. But this time we will also add the ArgoCD abstraction. So this Bastion cluster will be already GitOps compatible. And now, when we have a fully GitOpsified Bastion setup, everything is ready to deploy a real control plane, a real private AKS cluster, because we already have a bootstrap environment on top of this private network. And by real, I mean it will be full-fledged AKS cluster with a separate Kubernetes control plane and multiple highly available nodes. So something that is ready for production. It will be our Emir, this main control plane that Juan was talking about in the beginning of the presentation. Now it will look like that. Bastion cluster, thanks to Crossplane and Argo, will deploy the main control plane in fully GitOpsified manner. Now we will not use uptest for that. We will use a full-fledged GitOps mechanism to deploy. Argo will apply Crossplane resources, and Emir is going to be provisioned. And now the main control plane is ready. So basically we have a powerful setup with ArgoCD and Crossplane on top, and everything is ready to deploy arbitrary infrastructures. Now you have a capability to deploy anything. Kubernetes cluster, virtual machines, networking databases, whatever you like. Crossplane is capable of handle them all, and Argo is providing nice GitOps mechanisms to apply Crossplane resources. So that's our Bootstrap solution. To recap super quickly, we have 4 main stages. First one, uptest within a standard runner. It deploys a Bastion environment and registers the Bastion VM as a GitHub self-hosted runner. Stage 2, deploy a Bastion cluster on top of this Bastion VM. Stage 3, deploy the main control plane. And stage 4, already consuming infrastructure in a nice API-driven manner. So that's it for the solution, high level. And obviously, we face some challenges with implementation and production. And Juan will share how to run this stuff in production, what we discovered.
Yeah, of course. Lots of moving parts, lots of challenges. And the first one is that we found out the hard way that ArgoCD is not really eventual consistent. At some point, it fails and it stops syncing. And it also needs to respect a certain order when creating resources, especially, for example, when we create a Crossplane provider and then we provision a provider config. If the provider is there, the provider config will fail, the whole ArgoCD setup will be in an error state until you fix it. So, yeah, as Yury called it, we had to sail on an ocean of sync waves in ArgoCD, or our ArgoCD manifests. We have 342 sync wave annotations. It's not steps, but annotations. So every resource needed an annotation, and every resource needs to be deployed in a very specific order for everything to work consistently. There is a very good video from Victor. You can go watch it. There is a rant that he also has regarding this and why Argo needs to do something probably about this. Another challenge we faced was on how we delivered updates to our private cluster. Well, we have a package, that configuration Crossplane package has all our compositions, and we need to propagate these throughout our Emir cluster, but also through the control plane itself. Well, again, we used GitOps to do this, and also we use some CI/CD magic to sync the package with the package provider versions with the actual provider deployed versions on the clusters, which faced another problem here. How do you upgrade and downgrade a provider and keep it in sync with your configuration? Well, you need to have a very fine balance. Upgrading normally is not an issue, but downgrading could be, and you need to have both your configuration package and what do you determine there on your crossplane.yaml or abound.yaml file version with what you deploy in your cluster. So again, GitOps, CI/CD, and some magic, we made this balance work. And then also, thanks to uptest, we were able to test the new features. Before we had this setup, and launching a new feature was a bit of a gamble. We didn't know if it would break stuff, and of course, having a centralized control plane, breaking is not a very good thing, so we really need to test everything, and we really need to be able to test every single small module that we update instead of the whole thing, because our control plane is quite big, and it takes quite a long time to deploy. So yeah, we can run now with uptest dynamic control planes. We can spin up a cluster or spin up a small component, see if our changes work, get a green or a red on our pipeline, and then delete that dynamic cluster. And now we're going to show a small demo. It's actually going to be just a bit of how we do this on GitHub. And let me find there we go. And the first thing is that we have two pipelines here. As Yury explained, we have the first stage in which we deploy an Azure private VNet with a Bastion machine. This is done through uptest, and I'll open the pipeline down here. And what we really do here, and I'm not going to trigger this because it takes 15 minutes, and unfortunately we don't have that much time, but I'm going to show it. What we do here is we just deploy an X resource group, of course, an X VNet, and an X Bastion. X Bastion is just like a Bastion resource from Azure, and also a VM that has some extensions installed, and also self-registers to GitHub as a runner. So we run this pipeline, and we get a private VNet with a Bastion deployed, with a VM Bastion deployed, and then that VM gets self-deployed as a self-hosted runner on GitHub. This is important because in our next step, in our next pipeline, we're going to select that runner to deploy our control plane. And this one I can run it. I'll show you how long it takes. First time is a bit longer because, of course, we need to deploy everything, but the subsequent times we just deploy a new package, we test everything on the process, and it will get deployed if everything is green. So I just choose my branch in this case because this is a demo, and then I need to choose a target environment. I choose development, so nobody shouts at me after the talk. And then here we can choose if we can skip the deletion of our resources. This is important because if we want to just check do a dynamic test, we put this to false. It will spin up a cluster, or it will spin up a separate test environment, test the feature, and then clean it up afterwards. So I'm just going to run the workflow. And while this runs, I'm going to show you where everything comes from. And we have this Emir GitOps repo. It's very basic. We have our Emir folder, the bashing configuration, and what we call base. And basically, everything comes from here. We have our functions. So we use these functions. We also have our providers down here, as we can see. And this will get synchronized and deployed in the cluster every time we deploy a new one. Or actually, the actual cluster is listening to this. So any changes that we make here will be also automatically synchronized by our cluster. That's why it's important also if we're going to make a change in this repository and we don't want to break anything higher up, we can make a small cluster, spin it up, test it, and see what happens. So this is running right now, and yeah, it's about to finish. So it took, 53 seconds, and the actual deployment took 18 seconds. So all our tests run. Our dev cluster has the latest version on this branch, and we know it works. So yeah, it's pretty neat. So this is very cool, but how this affected our day-to-day operations? How did we see this impact ourselves, my team, while developing the cluster? Well, you can see that our workflow run success went almost to 100%, 92.5. That's pretty nice. Before this deployment, or production deployment that we call, our success rate was not very nice. We had like about a 60%, and this was because we had some timeouts. As I said, some deployments would get stuck, some things wouldn't work, and then the pipelines would just time out and fail. So we increased our successful runs, and we also can see that now we're way more confident when merging PRs. This is the mean time that it took for us in days to merge a PR, 3.2 days. Now somebody puts a new PR, automated test run. Mostly on the same day, we get a PR approved and merged. For now, it's a manual process, but of course, we want to automate this. And when we're confident enough that we can auto-merge PRs based on some tests, we will do that. So it will be almost instantaneous. And then, yeah, we can see here that our production deployments are now way more frequent and more reliable. There's been 50 deployments when this screenshot was taken, but I know that my team was making some changes last week, so we have some more now. So 50 deployments to production in about 4 or 5 months. I think it's pretty nice. So to wrap it up.
Yeah, thank you, Juan. So incredible business impact. Thank you so much for sharing it. Just to wrap up the solution, right? So we have a cloud-native solution for air-gapped environment. We have a full GitOps right after the second bootstrap, right? And the complexity is hidden by Crossplane. So the actual platform consumers, they have a minimalistic cognitive load, and we don't have to fall back to some form of legacy infrastructure as a code. Everything is extensible, reusable, and GitOps compliant. Last but not least, very important part that every stage in the story is actually testable in isolation, right? So there's a lot of moving parts, like it's a long process to bootstrap and deploy to the final environment, but every piece, every stage is testable with a test in isolation, and the cross-plane compositions are also reusable. So for example, we are using the same composition for Bastion cluster in the main control plane, so we testing the cross-plane code on every stage and our overall solution itself. So yeah, that led to this business impact. We have a high confidence and high reliability on our test pipelines and deployment pipelines. So that's it for us. Thank you so much, and we are happy to answer any questions. Thank you.
Any questions around there?
Hi, Dan, Confidential Minds, we are also locals. Is your egg ready to to grow a chicken on completely non-terraformed ground? I mean, is it like ready to run in completely walled kind of environment, like completely air-gapped, or you still rely on some external repositories, registries, etc.?
Yeah, so for now we rely on the public repositories from Outbound and our public or internet connected GitHub. But in the future, like this could just be connected to an air-gapped environment. We designed this so it will fit in our production infrastructure, and there we have a private GitHub repo, so we can just copy paste basically the GitOps repo there, and also we have a registry in there as well. So we just need the images that Crossplane needs to run, mostly the providers and the functions, and we need the GitOps code, and that's it.
Have you tried like this EXO operating system images maybe to feed with all possible proteins, all possible images that they need? So of course we cannot make an image of Kubernetes cluster, but to make it start faster, is it possible like to have all the images there on board and just
no
pooling even from local registries? It's all already there when the cluster is when it's initiated as a node.
We haven't tried that actually, because to be honest, we haven't started yet with the production supply deployment. That's a complete different world. But all comes from some what they call golden images. I guess we can bake in the images inside those golden images if the team who manages the VMs are nice enough with us.
Yeah.
But yeah, technically it's possible. Yes.
Cool stuff. It's really inspiring. Yeah.
Thank you so much.
Thank you.
Cool. We maybe have one more question. Time for. Yep.
Very much focus on the Git going from the Bastion cluster to the main control plane. Do you have like some Git instance that is mirrored or synced in some way inside the air-gapped environment or some tunnel? How does it go from after the Bastion is done doing the initial stuff to sync changes from GitHub into the cluster?
So well, right now it runs all on public cloud. So the cluster has access to GitHub. We run a GitHub enterprise, which is private, but the cluster has access to it. The way it works in our production infrastructure, there is a Git instance down there. And the process to sync the code is a bit too complicated. I think I just have 1 minute and I won't go into the details, but there is a process. Anytime like some code makes it to a main branch, there is a whole automation behind that makes a copy to the inside GitHub repository, or Git repository, not GitHub, Git.
Cool. I think that's it. Thank you very much for your talk.
Thank you so much.
Thank you.